So how do routers work, and what do we actually need routers for? Well, let's consider first that we start with a local area network. So here I've got three computers, A, B, C. They all have IP addresses that are all on the same network. So they're all 192.168.1. something. This is 5, 6, and 8. They're all connected by a switch, which means that these IP addresses don't really matter so much. They're going to be communicating with MAC addresses through that switch. But the problem is they all are communicating within this local area network. They're limited to the 192.168.1 local area network, and all of their ARP requests, anything that they send out on the broadcast, is going to be limited to the broadcast IP address, which is the last IP address in this particular network. So for a /24, it's 192.168.1.255. Okay, that's going to be the broadcast IP address for these computers here. Well, the question becomes, I've got the internet over here. I've got Google and Newegg and Amazon. How do I actually communicate with those different devices, those different IP addresses across the internet if all of my communication is limited to my local area network? Okay. Well, now we need a router. And so we can add in right here a router, and what a router does is it routes between IP networks. So for example, on this side of the router, it's going to have an IP address 192.168.1.1, but it's also going to have a public IP address 74.84 12.161 or something like that. Okay, some IP address that's on the public network. These are private IP addresses. The 192, the 172 dot, and the 10 dot are reserved for private use. But over here on the public network, we have a variety of different IP networks, different addresses. And the router's job is to translate from one IP network to another IP network. And so the router connects our internal local area network out to our wide area network, or the World Wide Web. Okay. Now you may be wondering, well, how does that work if this 74.84.12 isn't on any of these? How do we get from here over to one of these other networks like Google or Amazon? And so the reality is this cloud, or the internet, is actually a huge network of routers. So kind of like what I have drawn down here. This is a 3-router network. You'll have 3 different routers, and each router has an IP address on 2 different networks in order to get from one side to the other. So if I'm trying to traverse from the 192.168 network all the way over here to a 10 dot network, I go over to this router. This router knows that there is a route to eventually get to 10 dot, but it has to go from 205 to 172 and then 172 over to 10 dot. Okay? So these routers are going to create that route, but this router needs to know what that path looks like. And so in order for the router to work, we actually have to add in a routing table. Now in a setup like this, where we just have a local area network and the rest of the internet on the other side, the routing table is actually very simple. Essentially, the routing table keeps track of which port will get you to which IP network. So it has one entry that says that whatever this port is, we'll call it port 0. Port 0 goes to 192.168.1. Okay, so that's one entry in the router table. We'll say, just make one right here, port and network. And there's some other information in there as well, but this is just an example. So port 0 is 192.168.1.0. Now, if it wants to reference the rest of the internet, it's going to say port 1, and it's going to say 0.0.0.0, and it's going to be a /0. This is a /24, indicating that there's 24 network bits, or all of this is the network bit. /0 says there are no network bits, or all of these IP addresses are on the same network. So it's essentially saying go out that way for anything else. This is the 192.168.1, go out the other way for anything else. And so the rest of the internet then is kind of responsible for figuring out, well, how do I actually drive over to this 172.217 or get over to 184 or 72, those are going to be in different locations. And so the internet being made up of routers, each of these different routers is going to have a routing table, and eventually it's going to direct that traffic where it needs to go. Okay. So for example, over here, we might have a routing table for, I'll just number these guys. Here's router 1, router 2, router 3. So router 1 might have a routing table that essentially says out port 0, we're going to go to 192.168.1, and then maybe out port 1 is everything else. Okay, so zeros. Now router 2 is a little bit trickier because it's got a 205 on one side, it's got a 172 on the other side, but this 205 also goes to 192.168. So we can't, in this case, just say, oh, just everything's out this side and everything's out that side. We've got to be a little bit more specific. So the routing table for router 2, again, let me just put port here and network. Okay, and again, we're simplifying this just so that we can kind of see how the router routes stuff. There's some more information in there, including what interface IP address is there, and if there's multiple paths to different networks, there's a metric in there as well. So port 0, we know, goes out to the 205.58.64.0 network. And we also know out port 0 is the 192.168.1 network, and there might be other networks that direction as well that we would keep track of. Outside port 1, we have 172.8.41. some network ID there, and then we also have 10.0.0.0, and maybe port 1 is also the kind of catch-all for every other network. Maybe on this side, these are the only two networks. On that side, it's all of these other ones. Okay? And then router 3 might be a little bit simpler. Again, I'm going to label these for sake of clarity. So we might have a port and a network. So port 0 might be everything, and port 1 is 10.0.0.0. Okay, so a little bit simpler on that side, but realize, so the internet is going to be made up of routers, and those routers are all going to have these routing tables that essentially tell the router where to send traffic based on what IP address it is. If it doesn't know where it's going or how to get there, usually it's going to have a catch-all with this 0.0.0.0 that essentially says anything else go that way, but it at least have one network that it has as a specific port on that network. Okay. So that's kind of how routers work with IPv4 and addressing, kind of building those routing tables so that we know where to send information so that it can actually make it to its destination from an internal network out to an external network. Now, while we're on the topic of talking about this internal network going out to an external network, I mentioned that these addresses are private. So the 192.168 .0.0/24, 172.16 to 31/16, and the 10 address space. These are what are called private non-routable IP address spaces. So you can use these on a local area network, but they never show up out on the internet, and they're non-routable. The internet won't actually route them places because they're reserved for local area network use only. Now you're starting to think maybe that's a problem, because if computer A wants to go talk to Google, computer A is going to send out an HTTP request out to Google. Google is going to want to respond to that. Well, how does Google respond to 192.168.1.5? It can't respond to an internal IP address. Okay? And this is where PAT and NAT come in. Port address translation and network address translation. PAT and NAT. Network address translation is a feature of some routers where if the router has multiple external addresses, so maybe it's got a pool of 10 addresses that it can use that are all public IP addresses, as something inside has a conversation with something outside, network address translation that this router is going to do is essentially going to assign one of those IP addresses to computer A. So let's say that it's 162 instead of 161. So then the router, when it sends that packet on respond towards Google is going to send it out with 74.84.12.162 as the source IP address so that Google can respond to that public IP address. And then the router is going to translate back from that public IP address back to the 192.168.1.5. Now the problem with this is that public IP addresses are very limited and therefore very expensive. So if you have a company that has 100 or 1,000 computers inside of it, that could become exceedingly expensive to have an external public IP address for every internal device. And in fact, it's impractical. Nobody does that. So the reality is we're going to use what's called PAT, or port address translation. And so what that means is the router, instead of assigning a unique IP address to each computer inside the network, it's just going to assign a specific port. It's usually going to be one of the higher range ports. So it might be like 74.84.12.161, and then we indicate a colon for a port 13,768 or something like that. So it'll go ahead and put that as the source IP address and port so that Google can respond to the router at that specific port number, and the router can then translate that back into an IP address inside the network. Okay. And so the conversation that I have with Google from computer A here, 192.168.1.5, is going to go through my switch. The switch, based on MAC addresses, is going to send it to the router. The router is going to be that default gateway. That's why it has that IP address. It is my route to other networks. Default gateway there. The router is then going to translate my internal network into some public IP or IP and port number combination so that I can interact with devices out on the internet. I'm going to look at this routing table, know that port 1 is my route to all other networks. I'm going to go out into the cloud. The cloud is going to be a group of routers, and each of those routers are going to look through their routing tables and direct my traffic until eventually it's going to make it to Google. Google's going to get my request. They're going to respond. It's going to go back through that network of routers. Might even take a different path to get back through those routers all the way back to my original router, where they're going to look at what IP address and port number Google sent the response to. My router is going to translate that back to my IP address, send it to the switch. The switch is going to go ahead and send that up to me, and then I will have had my request from Google.